Hello everyone, this video is being made to help demonstrate my project and talk about some of the technologies and resources we use for the development of the project. So to start off, I guess I should show the Unity project itself. We ended up creating, for this project, we sought to look into the ways that one could develop an AI for a Unity project based on data collected from players. Now, unfortunately, due to circumstances relating to the recent pandemic, we weren't really able to collect that much data for this testing. But in order to prove a proof in concept, we decided to create essentially a Google Colab notebook that would use the Keras machine learning algorithm tools. And Keras, what it essentially does is it allows you to really quickly make models that will take in some data and then transform it into a prediction for an appropriate variable. So, for instance, in our final proof of concept, we collected information on the status of a board in the game, including things such as the position of the ball in the game, the position of the different game pieces. And we then, after collecting that data, we turned it into a form that the Keras network would be able to understand in the form of an 11-item vector, and fed it through a network of nodes that would apply matrix transformations to it until we got a single value. And that value I'll explain exactly what role it plays in a little bit. But for the project itself, we use the Unity engine. And so I'm going to real quick click start/join a game. And you'll see here that we now have an overhead view of a game board, including 2 goals, 3 pieces for each player, and that little dot there is actually a ball for the game. And so, in the end, what we decided to do is to have the game collect the status of the board after the ball stops from a player's turn, and place their goalie in an appropriate position based on that goal, based on the provided variable from that model. Now, one thing we realized over time was that there could potentially be issues if the user didn't have Keras installed on their machine, or with getting Python to fit with the Unity engine, which uses C#. So what we ended up doing is sending this data to a cloud service that would host the model inside of it, and it would then use that model to make the prediction and send back an HTTP response to collect, that would in turn consist of a single variable, which is the horizontal position that the player's goalie should be relative to their goal. And one thing I will take note of is the fact that this actually takes into account whether or not it takes into account the fact that the second player will have a reversed view than the first player. So here you can see that we're collecting information and then sending it into a request to this cloud function here. And so it has to wait for that to return, but after it receives a value, it then repositions the correct goalie using this get root request routine. And so for the data collection itself, we used simply a PHP server, which we could send HTTP requests to in order to store information about the board. Not all the information got used in the end, but we made sure to keep it anonymous while also placing it in a data string that could be transformed later on for our notebook. And so as for the project itself, basically you have the start screen where you can choose to either send data or not to send data, and to get instructions. And then you can choose to either host a game or act as a client. Now I'm going to real quick just click host and client on the local host address, which is what it starts out as. Real quick, I'm going to start as a host on the Unity project so we can see the so that we can see it sending the data and repositioning. And so now that you've joined, if you wanted to join a different IP address, you would have to download the Global Protect VPN so you could treat it as if you were on the same network, and then connect using the IP address of the second player, which they would have to provide you with. And so here you see as a first player, I can either choose to move or shoot the ball. If I click move, I can then pick a character and move it around, placing it wherever I want to. And then when I'm finished, I can just right click and it'll be done. And then I can also shoot the ball once I am finished. And there's like a two-way targeting. There's picking where to hit the ball from, and then there's where to hit it direction-wise. So in a moment, you'll see that the ball will stop. And I'll go back to the client side where I now can control this camera. And you'll notice that the pieces will have moved position based on the string. You'll notice it has debug log of varying values, which that is what we use to send information to our server, and then we get this value 29.194464. And so what that tells us is that if we look at the goalie here, they have now moved to the Z position 29.194464, which is the exact position that we chose that the server recommended for that player. And so I can always move the red characters as well. Like, let's say I move this guy over here. And then I can also shoot the ball when I'm done. Now I can look this way, but I'm going to instead look the opposite direction just so it's a little easier to see the character change in their position once the request goes through. And so you see now it's repositioned the goalie automatically. And if we go back to looking at the log here, you'll see it's given a value of 320168, which, if we look in our scene here and click on the goalie to the red goalie, it will now have gained a Z position of negative 32.1873, which might seem confusing until you realize that our algorithm takes into account from the player's perspective. It sends the information from the player's perspective, and it moves the piece from the player's perspective. So our algorithm has completely positioned this piece based on the suggested positions. And so basically what you can do is you can keep shooting the ball until one player scores a goal. Ooh, just short. So I'm just going to score on myself, even though it works for both players. But you'll see that it changes the score on both the client side and on the testing side. And so that's most of what we have to, that basically is what we really needed to prove the proof in concept. We're able to send the information and use a machine learning model to make predictions and influence the game in question. Future research could go into seeing if it's possible to implement the models in the game itself rather than from a server, and also looking a bit more into the framework that we use, which was the MLAPI framework, which later turned into Netcode near the end of the year. Thank you for listening, and if you have any questions, feel free to post them in the comments. Have a good day.